नमस्ते बेटियों, खुश रहिए। I JV Muskan Kumari from the Department of Science and Technology, and I'm working here as an assistant professor in JVWU Women's University and Faculty of Education and Mythology. So today's I will discuss the sessions with you. That's name is HDFC, Hadoop Distributed File System, isn't it? So Hadoop Distributed File System are basically what are the working of that ones, what are the architectures of Hadoop Distributed File System, why it necessary today's Hadoop Distributed File System, isn't it? So these all things or points we will discuss in this session. So I'm just going to share some files which will help you to understand these all points to make your understanding better. Okay, so here, Hadoop distributed file system. What is the basic requirements of the Hadoop distributed file system? Okay, so Hadoop file system was developed by using the distributed file system and design. Hadoop file system is basically developed using the distributed file system, and it is run on the commodity hardwares also. Unlike the distributed SDFC, it is highly fault tolerant and designed using the low cost hardwares also. And HDFC holds very large amount of data and provides easier access, isn't it? Large amount of data provides you the easier to access them. To store such large data, the files are stored across multiple machines. You are storing that files into the multiple machines because it is not possible that too much storage you have in a particular systems or the particular system, isn't it? Particular system and machines. So these files are stored in the redundant fashions to rescue the systems from the possible data losses in the case of the failure. So what you will do, suppose you are using the replica and using the duplicate files, you are making the duplicate files. Suppose there are some files which is very important and confidential for you. So what you are doing, you are placing that same files into the different places in your particular system. You are storing that files into the different locations. Clear? So suppose you are storing some files into the documents folders and storing some into the C drive, D drive, E drive, whatever, isn't it? So what you are basically securing that data from being the failure, isn't it? So this is only happens in the case of a small size of data. You can make multiple duplicate files and store in your particular system, isn't it? But if you have a large amount of massive of data, suppose 3 GB, 4 GB data, then it is not possible that you will place that data into your system at different locations. Why? Because your system storage has limited, isn't it? So you need extra another systems or another machines by which you can store that data from the another failures, isn't it? So the files are stored in the redundant fashion to rescue the system from the possible data losses in the case of the failures also. And HDFC Hadoop distributed file system also makes application available for the parallel processing also, isn't it? So if you talk about the some features regarding the Hadoop distributed file system, then we will say like that it is suitable for the distributed storage and processing also. Hadoop provides the command interface to interact with HDFC, and the built-in server name of name node and data node helps user to easily check the status of the cluster where the set of data is stored, and streaming access to the files data also. And HDFS provides file permission and authentication to access that data set files. Okay. Now, if we talk about this architecture, HDFS architecture, we can see here that there is a client who are using the metadata. ops, and that is the name as the name node. And here are the data nodes from where data is going to be read. And whenever client want to write, it means they are storing the data into the different data node machines, isn't it? And the replication of this data is also stored in the another data nodes also for as a backup, isn't it? So this is rack 1, this is rack 2, which is containing the data nodes, isn't it? Here the clients are reading the data and they are write the data, storing that data, and this whatever the data is fetched as per reading, so that data is uh, containing here as a metadata ops, and metadata that has their name, replicas, homes are in this will be the path of that data also, isn't it? So HDFS has the master slave architecture and it has the following streams like following elements like what, name node, data node, isn't it? What is do you mean by the name node? Now if we talk about the name node, then what we will tell you about the name node. So name node is the commodity hardware that contains the GNU Linux operating system and the name node softwares also. It is it is the software that can be run on commodity hardware. The system also have name node as the master server and it does the following tasks like manages the file system namespace, regulates client's access to system. It also executes file system operations such as renaming, closing, opening files and the directories, isn't it? Now, if we comes to the next architectures like the HDFS architectures name like data node. What is will be the data node? So, if we talk about the data node, then we can say that one data node is a commodity hardware having the GNU Linux operating system and data node softwares. For every node in a cluster, there will be a data node, and the data node also manages the data storage of their system. Data node perform the read-write operations on the file system as per client request. They also perform operations like the block sorting, deletion, replications according to the instruction of the name node. Now, if we talk about the block, what is the important role of block in the HDFS? So generally the user data is stored into the file of HDFS and the file in a file system will be divided into the one or more segments for storing and managing that files very fastly. Stored in the individual data nodes, these file segments called the block. Okay, in another words, minimum amount of data are stored in a file, and that files is known as the block. Uh, block and HDFs can read write is called a block, and because that read and write operation is performing on that files, isn't it? So the default block size is 64 MB, but it can be increased as per need to change the HDFS configuration. Okay. Now, if you talk about the goals of the HDFS, what is the goal, basic goals of the HDFS? What is the basic requirement of the HDFS, isn't it? So we can also say that the fault detection and recovery, since HDFS uh, Hadoop distributed file system includes a large number of commodity hardware. Failure of components is frequently used. Therefore, HDFS should have mechanism for quick and automatic fault detection and recovery. Okay, so if we talk about the next, use data set. What is the use data set? What is the main goal of use data set? So HDFS should have hundreds of nodes per cluster. There are many clusters in the Hadoop. So each cluster contains the hundreds of the node to manage the applications and the huge amount of the data set. Okay, so now if we talk about the goal of the hardware and data, so we can say that the request task can be done efficiently when the computation takes place near the data, and especially where huge data sets are involved, it reduces the network traffic and also increase the throughputs. Now if we talk about the starting HDFS, then we can say that initially you have to format the configured HDFS file system. Open name node HDFS server and execute the following commands like but Hadoop name node dash format. After formatting the HDFS, the starting distributed file system, the following command will start the name node as well as data node cluster. Okay. Now, if we talk about the more mm, commands like the start dfs dot sh. What is the meaning of this ones if we talk about this? So this is basically used for the starting the name node as well as the data node as clusters. So if you want to listen files in HDFS, then what? After loading the information into the server, we can find the list of files in a directory, status of a file using the ls command, listing command. Given below is the syntax of ls that you can pass to a directory or file name as an argument. So you can write like what? A Hadoop underscore home slash bin slash Hadoop FS and hyphen ls listing arguments, right? So inserting data into the HDFS. Suppose if you want to insert some data into the HDFS, then what commands we will use? Assuming that the data in the field called file.txt in the local system, which is ought to be saved in the HDFS file system, and for that there are some following steps are required file in the Hadoop file system. First step is what? You have to create an input directory, isn't it? So Hadoop underscore home slash bin slash Hadoop fs and hyphen make directory slash user slash input, isn't it? So this is basically used for creating the directory, and you all know that you all very well know about creating the directory, how you will create that directory. And now if we talk about the step 2, like transfer and store data file from the local system to the Hadoop file system using put commands, then we can directly write Hadoop underscore home slash bin slash Hadoop fs, then hyphen put slash home and their file name slash user slash input. Now, for the step 3, if we talk about the verify the files using the listing command. So we can directly use Hadoop underscore home slash bin slash Hadoop fs hyphen ls slash user slash input, and that it means we are verify the files with the ls commands also. And if you want to retrieve the data from the HDFS, then assume we have a file in HDFS called the out file. Given below is a simple demonstrations for retrieving and required file from the Hadoop file system. So step first, initially view the data from the HDFS using the cat command. Then you can directly use here like what? Hyphen cat user output of files. And if you want to get the file from HDFS to the local file system, then you can use the get command. Here you are using hyphen get user output home Hadoop, and where the file is directly kept, you can use that path name. For shutting down the HDFS, For shutting down the HDFS, you can shut down the HDFS by using the following command. Like here what? Stop hyphen SDEFS dfs.sh, whatever we are using it. So in this session I have discussed the Hadoop distributed file system HDFS, their characteristics, or you can see their features, isn't it, their architecture, what is the name node, what is the data node, what is block, the goal of the HDFS, and several commands we have used to store the data files, retrieve the data from HDFS, get files from HDFS, so many. So if you have any problems in this session, then please share your query by using the putting your query into the comment section box, where I will see and discuss that your query in the next session. And please read this session from different informative sites, isn't it, and different standard book also. And there might be some question will arises from this, like what is the HDFS architecture, please explain that architecture with an example, explain the features of the HDFS. Now what is the role of block in HDFS architecture, and please define the goal of the HDFS. Then you can write these all the points which I have discussed today with you. Okay, thank you.